Hello everyone, welcome back. This is Engineer Hussein Mosapi, and in this video we'll be looking at what is known as rationalization of surds. So let's just say rationalizing a surd denominator. Alright, so before we begin, don't forget to hit the like button and subscribe. Alright, so to start with, I want to give you a spoiler. In as much as I have mentioned that we're rationalizing a surd denominator, which simply just implies that we're rationalizing the denominator, it's not just restricted that you can only rationalize the denominator. If you want, you can as well rationalize the numerator. It's just that when dealing with expressions where surds appear in the denominator, it is just a normal practice to eliminate all surds in the denominator. That is where possible. And that entire statement just means that we're just rationalizing the denominator. Now let's look at the types that we have. So, types. So the first type is where we have this case. So we might have a case where we have 1 over the root of what? A. Where A is equal to, or let me just say, is a member of all real numbers. So let me just say where A should not be negative. Okay? Yeah, that would make more sense. A should not be negative. Alright, so what you need to know is this. If you've been given the root of A as your denominator, all you're supposed to do is to multiply the top and the bottom by the root of what? A. Remember, the top is called what? The numerator, or the bottom is called what? The denominator. So this guy is Mr. Denominator. Alright, so we basically just have to rationalize in this manner. If I have 1 over root of A, I'll say times the root of A over the root of A. This means that we'll get 1 multiplied by the root of A. We'll basically have the root of A, because 1 is an abstract figure, it doesn't really change anything. Then root of A times the root of A will just give us A. And that's how we rationalize what? The denominator. We're basically just looking for a number at the bottom that is not rooted. Now that's for the first type. Now the second type is the interesting one. So for the second type, you might have something like 1 over A plus or minus root of B. It could be the root of A plus or minus B, or let me just say it could be this as well, root of A plus or minus B. Or it could also look in this manner where you have root of A plus or minus root of what? B. All these are possible cases. So when I say plus or minus, it just simply means that it could be a plus or a minus that has been put there. Let's just try and understand using this guy. So if I have 1 over A plus B, where B is square rooted, what I'm going to do is that I will multiply the top and the bottom by the conjugate of the denominator. So I have 1 over A plus root of B. So I'll multiply this by the conjugate of this guy. Now remember, if I have A plus B, the conjugate of A plus B is simply A minus B. I hope this is clear. So if I have root of A minus B, and the conjugate of this will simply be root of A plus B. When I say conjugate, it simply means that I'm looking for the same expression, but the sign in between will just shift. If it was negative, to be positive. It's positive, it's going to be negative. So that's what I'm trying to illustrate. So the conjugate of the denominator will just be A minus root of what? B. So remember, we're multiplying the top and bottom by the conjugate of the denominator, which is A minus root of what? B. Now when it comes to conjugate pairs, if I have A minus B multiplying A plus B, just multiply the first with the first and the last with the last, which means you have A squared minus B squared. Don't waste your time and say A times A, then again A times B. In between, you just get a 0, so it's just the first and the last with the last. Remember that. So, which means that if I had to 4 out, I'll get the top being A minus root of what? B over the bottom. Remember, the first with the first will simply be what? A squared. The last with the last will be minus root of B times root of B, which just give me B. like that. So I have s squared minus b, and this will be rationalized form. Let's not forget that. Now, I know you're wondering, why am I saying the first to the first and last to the last? Let me explain this clearly. Imagine you have a plus root b multiplying a minus root what? B. We know a has to multiply all the elements in the second parenthesis, which is this guy, for a to be done with expansion. So this is going to be a times a, giving you a squared. A times minus root b, that will be minus a root b. Then again, I'll do the same thing with root b, multiplying this guy and that guy. Root b times a, that will be plus a root b. And root b by minus root b will be minus b. Now, this part here is going to give me a 0. So I get a squared minus b. That's why I said the first with the first and literally the last with the last. Now, the same thing, if I had a minus here, I would put a plus there. It's literally the same concept. Even if I had like one single value there, like which is a plus, put a minus, that's literally the concept that's behind it. So always get the conjugate, which is like the opposite of the same expression you have, but the sign that's present in the middle changes. So you understand this clearly if we look at basic examples. But one thing you should remember is this. Every time you're simplifying surds, always make sure that you rationalize the denominator where appropriate. Make sure that when you write that expression, make sure you have as minimum roots as possible. And make sure that they are small and simplified as they can be. Please keep that in mind. And always apply all the rules that you have learned on surds. All the rules and techniques that you know, apply them. So let's look at basic examples that we can use to understand the knowledge behind what we have just from explaining. So imagine I have, let's say I'm having something that is saying 2 over root 4. Let's say I've been taught to rationalize the denominator. So if we've been taught to rationalize the denominator, all we have to do is to follow the basic steps. So we're going to do the same thing literally here. So remember, if we have this kind, all we have to do is to say 2 over root 4, then multiply everything by root 4, the top and the what? The bottom. So remember, this divided with that gives you a 1, which means you're not really changing anything. So remember, 2 times root 4, that would be, I wasn't supposed to use root 4, let's use root 14 because 4 is an even number. So we're literally going to get a 2 in the end. So let's use 14 because root 14 is irrational. Alright, so 2 times root 14 is going to be 2 root 14. Then root 14 times root 14, that will just give you 14. Then at this point, you know, you can simplify this by saying 2 there, 1, 2, that's going to give you a 7. And you have root 14 over 7 to be your final answer. Now, basically, this is literally how you have to go about it. At times, I might make it a bit tricky and give you something which is of this nature. Let's say you have minus 4 of root of 7 over, let's say you have 3 by root of what? 5. So all you have to do is just apply the same knowledge behind it. You have minus 4 root of 7 over 3 root of what? 5. Multiply the top and the bottom by the bottom value that you have. You can just get the root value if you want, or you can get the 3 and the root of 5. But it's best to just get the root because you just want to eliminate the root that's present there. So you're going to say root 5 on top over root 5 at the bottom, since we just want to eliminate the root. But if you want, you can still put the 3 there and the 3 at the bottom. It won't really change anything. Just take it back to the same answer you'd have got if you just use the root of 5 over the root of 5. So this will just give you something like, if you multiply this by that, you will get minus 4 root 7 by root what? 5 over, now 3 times root 5 by root 5, you get 3. Then you're having root 5 times root what? 5. Now applying this basic knowledge that we learned about surds, we can say that we have minus 4. Now remember, this would be the root of 7 times what? 5 over 3 times what? 5, because root 5 times root 5 is basically 5. I hope we're on the same page. Now, with that in mind, we can just simply say, okay, what is 7 times 5? 7 times 5 will give you 35. So you will get minus 4 root of 35 over 3 times 5, which is what? 15. And basically, this will be your final answer because there's no way we can actually simplify this in any other simpler way that we can think about. Because root of 35 simplified can't even be simplified because you can't even pull out any even number and multiply it with a value that can help us have the whole number. So That will be our answer right there. Now, let's say we have the other type of problem, which is this case. Let's say we have 2 over the root of 5 plus 1. So we're going to say 2 over the root of 5 plus 1. So we can put this guy in brackets and multiply by the conjugate for the top and the what? The bottom. So it's going to be root 5 minus 1 over root 5 minus what? 1. Because we're getting the same thing, but just changing the sign that is in between. Then for the top, we're just going to say 2 multiplied by root 5 minus 1. But for the bottom, remember the first to the first and the last to the last. Root 5 times root 5 is 5. Then plus 1 times minus 1 gives you a minus 1. Then 2 times 5, 2 times root 5, that is 2 root 5. 2 times minus 1, that's minus 2. Over 5 minus 1, you can put this guy in brackets. No, let's not put that in brackets. Then we have 5 minus 1, that is what? 4. Then we can reduce this by pulling out the 2. We could have done this like literally without expanding it. So you can have 2 root 5 minus 1 over 4. Then 2 there, 1, 2 there, 2. You will get your answer, which could also be root of 5 minus 1 over 2. So all these are possible answers, this guy or the other guy. At times, they would put it a bit tricky, which is not really that tricky, where I would say 2 by root of 3 plus root of 5 over, let's say we have 4 root of 2 plus root of 5. So all we have to do is to apply the same knowledge. So we have 2 root of 3 plus root of what? 5 over 4 root of 2 plus root of what? 5. Now, since we're rationalizing the denominator, our main focus is the denominator. So we're going to get the conjugate of the denominator. But if at all we wanted to rationalize the numerator, we'll do the same thing, but just get the conjugate of the numerator. So this will be 4 root 2 minus root 5 over 4 root 2 minus root 5. Then you can just do up a data and solve 2 root 3 plus root 5 times 4 root 2 minus root 5. So 2 root 3 times 4 root 2, that's going to be 8 root. Since it's root 3 times root 2, that will give us a 6. Then you're going to say 2 root 3 times minus 5 minus root 5. So that will be minus 2 root 15, because we're doing 3 times 5 in there. Then we do the same thing with the root 5. Root 5 times 4 root 2, that will be plus 4 root 10. Then root 5 times minus root 5 to give you minus 5. Then you can simply just try to manipulate what you have and get a proper value. So you're going to get a case where you have something as 8 root 6 minus 2 root 15 plus 4 root 10 minus 5. So it's not in all cases that you might have something like this. Sometimes you might have something simpler than this. It says in my case, I didn't get the same value, I changed the roots so that you look at all the possible cases that you might have. So for the top, we're having 8 root 6 minus 2 root 15 plus 4 root 10 minus 5 over the first with the first, so you get 16 by 2. Then you get the last with the last, then minus 5. So this will give you 32 minus 5, so you get 8 root 6 minus 2 root 15 plus 4 root 10 minus 5. And this is over 16 times 2 gives you 32 minus 5, that gives you 27. And that will be your final answer. Now, it's not always messed up like this. It's not always crazy like this. At times, you might have something that is a bit just simpler than that. Let's say we have this over 3 root 2 plus root 3. Then we know that all we have to do is to get the conjugate of this guy. Put this guy in brackets. So 3 root 2 plus root 3. So multiply by the conjugate, which is 3 root 2 minus root 3 over 3 root 2 minus root what? 3. So all we have to do now is to 4 out. We can just 4 out the numerator. So it's going to be 2 times 2 root 3 times 3 root 2, which will be 6 root 6. Then 2 root 3 times minus root 3, which will be minus 2 times 3. Then root 2 here, minus 3 root 2, which will give us plus 3 times 2. Then root 2 times minus root 3, which will give us minus root 6. If we collect the like terms, we have 6 root 6 minus 1 root 6. Then you have, this will give you what? A minus 6. Then this will give you what? A plus 6. So this will cancel out and you get a 0. But 6 root 6 minus 1 root 6 gives you a 5 root 6. Sorry about that. 5 root 6. Then for the bottom part, this is for the top, which is numerator. For the bottom part, we're having the first with the first and the last with the last. So it's going to give me a 9 by 2. Then positive root 3 times negative root 3. We're going to get a minus 3. So it's like I'm having, what is 9 times 2? 9 times 2 is 18. 18 minus 3, we get a 15. So having 15 at the bottom. So if I pull this data and take it this side, like that, I'll be having 5 root 6 over 15. So I can reduce this 5 there 1, 5 there what? 3. Therefore, I'll get root 6 over what? 3 as my final what? Answer. So basically, that's what you have to do. It's literally the same procedure over and over again. So could have a plus or could have a minus. Nonetheless, we still do the same thing. So in a case where we end up having a question that would say, let's take for instance, we've been taught to say, let's say express root 2 plus 1 over root 2 minus 1 in the form of a root 2 plus b, where a and b are what? Integers, and hence state the values of a and what? B. So I'll solve it on the next part. So we're taught to express, to rationalize this guy. You see, we have root 2 minus 1. So all we're going to do is to get the conjugate of the denominator, which is root 2, then say plus 1, then it's going to be over root 2 plus 1. Then you can always do a data by the side if you don't want to mess up. So you're going to say root 2 plus 1, then times root 2 plus 1. So root 2 times root 2, that is 2. Root 2 times 1, that is root 2. Then 1 times root 2, that is simply root 2. Then 1 times 1, that is basically 1. So you have 2 plus 1 plus root 2 plus root 2. So you have 3 plus 2 root 2. That's what we're having there. 3 plus 2 root 2. Then you can also do that for the denominator. So this is for the top. Then for the bottom, remember the first with the first and the last with the last. So root 2 by root 2, you get 2, then 1, negative 1 by 1 gives you a minus 1, so you get a 1 at the bottom. So if you substitute this, you have 3 plus 2 root 2 over 1. So you're getting your final answer to be 3 plus 2 root 2. Remember, we were taught to express our answer in the form, so I'll just interchange this. We're taught to express in the form of a root 2 plus b. So it's the same as 2 root 2 plus 3. That's our answer. Therefore, it's easy to say that a is equal to 2 and b is equal to what? 3. Alright, thanks for watching. Don't forget to like and subscribe. Remember, slow progress is better than no progress. Never forget to strategize before becoming a statistic. Let's try to push for that what? A plus.